Hi students, how are you today? Welcome to Top Tutors, Toppers e-learning classes. Understand every single concept and be a topper. Today's objective. After this lecture, we will learn the answers for what you mean by charging a body, difference between charge and net charge, three methods of charging, that is as per the Cbse syllabus, which is coming in this chapter. Also, we will learn three more methods of getting charge on a body. Then how can you charge a metal sphere positively without touching it? So these are the objectives of this chapter. First, let us learn what you mean by charging. The process by which providing a net charge to a body is called charging. It means number of protons and electrons are not equal in the body. Net charge is sum of all the charges on a system. A charge is just an individual charge, which is that basic property of matter that is responsible for all electric and magnetic interactions. Charge can be greater or less than net charge. So actually, when you are saying charge and net charge, the contexts are different. All the body, which is made up of a molecule, which contain atom. Atom consists of proton, electron, neutron basically. Protons are positive charge, electrons are negative charge. So all the material have charge, positive and negative. But normally, number of protons and number of electrons will be equal. So their net charge is zero. They are neutral bodies. It contains charge, but effectively net charge is zero. But if the number of electron is more than proton or less than proton, then there will be a net charge. So we can say the body is charged. Then, methods of charging a body. The process by which providing a net charge to a body is called charging. Three main methods of charging are charging by friction or charging by rubbing, second charging by conduction, third one charging by induction, fourth one photoelectric effect, fifth one thermionic ionization, sixth field emission. The first three methods of charging is coming in this chapter: charging by friction, charging by conduction, charging by induction. These three topics we will discuss in details in this session. Other three, just an overall idea. Fine. So, what is charging by friction? Charging by rubbing. See this animation. We can see a neutral cloth and neutral PVC pipe. By rubbing, this neutral rag getting positive charge and neutral PVC pipe getting negative charge. What is the reason? Electrons from neutral rag cloth is transferring to PVC pipe. So PVC pipe is gaining electrons, so it is becoming negative charge. Cloth losing electron, so it is becoming positive charge. So this is what is charging by friction. The definition is the process of rubbing two suitable insulating bodies and transfer of electrons from one body to other is termed as charging by friction. Charging by friction is actually taking place between two insulating objects, not the conductors. That you have to take care of that part. When you rub two conductors, then it is not getting charged. But when you are taking two suitable insulators and rubbing each other, the electrons from loosely bounded body will be transferred from the other, and it will be charged by friction. That means by rubbing. So transfer of electrons take places from loosely bounded one to the other body. So other factor, what we can say is, when the two bodies are rubbing, they are getting thermal energy. So this is the one reason for the transfer of electron. And it is also depend upon the ionization energy or dissociation energy. Now, I have given two columns. In first column, we have glass, wool, ebonite, dry hair, woolen cloth. In second column, we have silk, amber, ebonite, rubber, plastic, polythene, comb, balloon. I told you suitable insulators has to be rubbed each other. Okay, so when glass and silks are rubbed each other, glass is getting positive, silk is getting negative. Wool or flannel rubbing with amber, ebonite, rubber, plastic, etc. Then wool or flannel is getting positive, amber, ebonite, rubber, plastic, etc. getting negative charges. Similarly, if ebonite and polythenes are rubbing, ebonite will get positive and polythene will get negative charge. Dry hair and comb. When you're rubbing comb on our hair will get positively charged, comb will be negatively charged. Woolen cloth and balloon. Woolen cloth will get positive, negative charge at balloon. So these are some pairs of materials what you have to remember for the examples. Next, let me ask a question. When a glass rod is rubbed with silk, glass rod becomes positively charged due to 4 options. A, protons are added to it. B, protons are removed from it. C, electrons are added to it. D, electrons are removed from it. What is the answer? Correct answer? Who can say? Yes, that is correct. So correct answer is option D. Electrons are removed from it. We know the first option, protons are added to it. Protons are located in the neutron, in the nucleus of an atom. So normally it cannot be moved from one atom to another. So protons are added is wrong. Protons are removed also wrong. A and B are wrong. C, electrons are added to it. When we are rubbing glass and silk, electrons on glass rod is loosely bounded. So it will be transferred to silk. So C option is also wrong. Correct option is electrons are removed from glass rod to silk. That is the correct option. One more question. Glass rod rubbed with silk and plastic rod rubbed with fur. Option A, attract each other. Option B, repel each other. Option C, will not attract nor repel. Option D, none of the above. Tell me the correct answer. Right. So A is the correct option. What is the reason? The plastic rod rubbed with fur, it becomes negatively charged. And the glass rod rubbed with the silk become positively charged. So we have negatively charged plastic rod and positively charged glass rod. So opposite charges attract each other. So glass rod and plastic rod, these two materials will attract each other. So option A is the correct answer. Now, charging by conduction. What do you mean by charging by conduction? The process of transfer of charge by contact of two bodies is known as conduction. See the animation. If a charged body is put in contact with uncharged body, neutral body, the uncharged body becomes charged due to transfer of electrons from one body to the other, from the charged body to the uncharged body. The charged body loses some of its charge. In the animation, you can see a negatively charged body is bringing and making contact with the neutral body. So negatively charged means it contains excess of electrons. When it's coming in contact with another neutral body, this electron will be transferred to the object. And they will share the charges equally. Suppose the charged body has 10 excess electrons. So what will happen? It will give 5 electrons to the other body. Okay, depends upon the size, shape, and material, but generally we are saying equally sharing. Okay, so the charge gained by the uncharged body is always lesser than initial charge present on the charged body, because the charged body is not giving all the charges to other body. They are sharing, right? Depends upon the factors. So after some time, both will have this equal potential. So when the potential difference is 0, then the transfer of charges will stop. Okay. Now, flow of charge depends upon the potential difference of both bodies. If there is no potential difference, then conduction will not take place. Positive charge flows from higher potential to lower potential, while negative charge flow from lower to higher potential. So positive charge is always flowing from higher potential to lower potential, while negative charge flows from lower to higher potential. So when we are saying charges are flowing, basically what is happening? Electrons are transferring, right? So when you are saying positive charge flow from higher potential to lower potential, actually electrons are flowing from lower to higher potential. Electrons are basically the moving from one object to another object, or transferring from one material to another material, right? So in charging by conduction, sharing of charge will take place, which depends on size, shape, and nature of the material. If the charged body and uncharged body both are same shape, size, and same material, then the charge will be distributed equally. First material, charged body has 10 positive charge, then it will give 5 positive charge to the neutral body. It means from neutral body, 5 electrons will be transferred to positively charged body. So by transferring, the neutral body become 5 positive charge. By gaining this 5 electrons, 5 positive charge has been neutralized. So remaining 5 positive charge will be so they both have the now same charges because both same shape, size, and nature of the material. So they can equally share the charges. Now, third method, charging by induction. What do you mean by charging by induction? If a charged body is brought near a metallic neutral body, the charged body will attract opposite charge and repel similar charge present in the neutral body. As a result of this, one side of the neutral body becomes negative while the other positive. This phenomena is known as charging by induction. Charging by induction. I have an animation here. See, here, first case, you can see a negatively charged body is bringing near to this neutral body. It was neutral in the beginning, right? When the negative charged body is coming near to this object, what will happen? The electrons near to this part, it will be repelled as far as possible. So this area, the negative charge will be, electrons will be accumulated. So automatically this area will become positive charge, right? So it is actually one area, both areas polarized. Here it is positively charged and here it is negatively charged. The reason understood, right? Because the negatively charged body is bringing but not touching. So because of that reason, the electrons in and the atom of this area will be repelled. Negative and negative will repel. So it will go as far as possible. This area, it will become negative. So automatically this area will become positively charged. Okay, positively charged. Now, when we are taking this charge back, what will happen? It will come to the same previous position, right? But by keeping like this, if you touch the other end, means if you are giving earthing, what will happen? These electrons which are accumulated in this area, it will flow to the earth through our hand, because earth is a ocean of electrons. It is received to receive as many electrons and it is also ready to give the electrons. So it is finding an easy path to earth. There's a potential difference is there, right? So electrons are flowing to the earth. So all these accumulated electrons flown to earth. So what will happen? The material, there is a deficiency of electron. So when we are removing this charged body, which we brought near to this one, near to this metallic object, what will happen? This positive charge will be distributed uniformly. Positive charge will distribute in the object, on the surface of this metallic body, but it is uniformly with equal space. It will be distributed on the surface. It will not go into the body, but it's on the surface. Charging by induction. See the second animation. We have two metallic bodies, spheres, which is mounted on insulated stand. Okay, when they are coming in contact, it will act as a single object. we are bringing a negatively charged balloon near to this end. So negatively charged balloon is coming here. So negatively charged body will repel the electrons in this area. Okay, so that will repel and move to the maximum distance it is possible. So this both the body was in contact, right? So this end is becoming negative and this end is becoming positive, right? See the body we are bringing. So this end is becoming positive. See this end is becoming negative, right? Now what we are going to do? We are going to separate these two bodies. We are moving this body. So what will happen? This body has a negative charge. Number of electron is more than the number of protons. And other one, this one, number of electrons is lesser than the number of protons. So when we remove these two bodies, what will happen? The first body will become positively charged and second body will become negatively charged. After removing their contact, they will become, this charges will be uniformly distributed. This all positive charge will distribute uniformly on this object and negative charge will be distributed here uniform. So we are getting both the bodies charged. One is positive and the other one is negative. But initially the source, what we are bringing near to this object, which is negatively charged balloon, we are not touching with this balloon on the material. Okay, we are just bringing close to that one only. So that is why it is coming under induction, right? We are calling it induced charge. Charge is inducing, correct? We are bringing near to this one, not touching, right? Not touching. Okay, clear. Now, this charging by induction experiment we can learn step by step. Once again. So first step, bring two metal sphere, A and B. This is A and this is B, supported on insulating stands in contact as shown in figure A, this one. Then bring a positively charged rod near one of the spheres, say A, taking care that it does not touch the sphere. So here we are bringing the positively charged rod. Is a positively charged rod. We are bringing near to this metal spheres. The free electrons in the spheres are attracted towards the rod. So this sphere is made up of atoms. Atoms contains electrons. In metals, we know the electrons are loosely bounded, so they can move from one area to another area. So when we are bringing a positively charged rod near, the free electrons will come close to this one. It will be attracted. Not all electrons, but in the surface, electrons will come more close to this part. So free electrons, some of the free electrons move to this end. So automatically this other end here, there will be a deficiency of electrons. So this part will become positive, okay, and this part will become negative. Now this leaves an excess of positive charge on the rear surface of sphere B. In sphere B, the backside, it becomes positively charged, deficiency of electron. Both kinds of charge are bound in the metal spheres and cannot escape. They therefore reside on the surface as shown in figure, because they are not coming in contact with this rod or not coming in contact with earth. So they cannot flow from this system of two spheres which are in contact. Now, The left surface of sphere A has an excess of negative charge, and the right surface of sphere B has an excess of positive charge. However, not all of the electrons in the sphere have accumulated on the left surface of A. As the negative charge starts building up at the left surface of A, other electrons are repelled by this. In a short time, equilibrium is reached under the action of force of attraction of the rod and the force of repulsion due to the accumulated charge. Figure B shows the equilibrium situation. So all these charges, here positive, here we have negative, here we have positive. All the system, this complete system will come in equilibrium, right? As the force of attraction, repulsion, all this net force will become zero, right? This negative and positive will attract. This negative and this positive will attract, correct? So entire system will become equilibrium. This process is called induction of charge and happens almost instantly. It will happen instantly. Okay, so this is induced. Without touching, we are inducing charges on the object. This area is negatively charged and this is positively charged. Now separate the spheres by a small distance while the glass rod is still held near sphere A as shown in figure C. We are keeping this positively charged rod as it is, but we are separating these two bodies at a small distance. The two spheres are found to be oppositely charged and attract each other. See, this is positive, negative charge, and this is positive charge, correct? So the oppositely charged spheres will have an attraction between them, right? Because of that reason, before this area was accumulated with negative charge and this area was accumulated with positive charge. Now what happened? After removing this positively charged rod, what will happen? The negative charge will accumulate this area and positive charge will accumulate this area. Remove the rod. The charges on spheres rearrange themselves as shown in figure D. Now separate the spheres quite apart. We are making them quite apart. What will happen? The charge on them get uniformly distributed over them as shown figure E. So the charge on body A, it will be uniformly distributed all over the surface of the sphere. The negative charge all separated, distributed with equal distances in all the surface. Similarly, positive charge. So this body has a excess of electron. This has a deficiency of electron. So one is become positive, another one is negatively charged. Now, so this induction, charging by induction, actually two ways we can do, two methods we can do. Okay, so first method by earthing, right? By earthing, by touching or giving a grounding, connecting to the earth, first method. So when earthing the induced conductor, the potential of conductor A becomes zero, right? We are just, see here we have a charged body, which is positively charged. We have a sphere here. So when you are bringing this positively charged near to this one, by induction, this area will become negatively charged. So automatically the opposite area will become positively charged. Now we are connecting this end with earth. It means we are grounding or earthing. These three lines we have learned before. It's the symbol of earthing. So what happened? This area there is a deficiency of this area there is a deficiency of electron. So Earth is ready to give electron. So electron will flow from Earth to the object, and this all positive charges will be cancelled. How many positive charges? 1, 2, 3, 4, 5, 6, 7. That many electrons will flow from the Earth to the object, and all this positive charge will be cancelled, and this body is getting excess of electron. So normally we know in electricity we will show the flow of current. Conventional flow of current is the positive charge. So in electrical diagram we will show the direction is in the direction of positive charge flow. But when we are saying positively charges are flowing, actually the electrons are flowing in the opposite direction. What is the convention? That is the system what we have to follow. Okay. Then if you remove this contact with the Earth, what will happen? This excess of electron which flown from Earth to the body will remain there. So this body will become negatively charged. So we can charge a body negatively by induction, by bringing a positively charged body near to the object without touching it and giving a grounding on the opposite side. This is one way of charging by induction. So to make potential zero, some electrons flow from the Earth to the conductor A. So when they are both are becoming, this area and the Earth is becoming potential difference zero, then the flow will stop, right? Flow will. If there is a potential difference is there, then only the charge will flow. Now remove the earthing of A, then conductor A will become negatively charged. Second way of charging by induction, that is by connecting induced conductor to a neutral conductor. So we can bring the neutral conductor and we can make them in contact or touch, or we can use some conducting cable between these two. So when connecting the induced conductor to a neutral conductor, the potentials between them will become equal. To make potential equal, some charges will flow from the object A to object B. Now remove the contact between A and B. Then conductor B will become positively charged. See, this will become positively charged, and conductor A will become negatively charged. So what we are doing, we are bringing a positively charged body near to a neutral body. So initially this was a neutral body, right? This is a neutral body. Then what will happen? This area which is near to the charged body, the electrons will come and accumulate this area because there is an attraction between positive and negative charge. Same time, the opposite farthest area will become equally positive charges. So it is polarized. Positive charge one end, other end negative. Since positive charged body we are bringing near to this one, closer area will become negative, farther area will become positive. Now we are bringing another neutral body which is B, same shape, size and material, and we are connecting these two by a conducting wire. What will happen? The electrons, this is a neutral body, right? But it is a metal conductor, so electrons are ready to flow if there is a potential difference. So there is a potential difference is there between this area and this body B. What will happen? Electrons will flow from B to A to make their potential difference equal to zero, right? So if there is 10 positive charges are here, to make them potential difference equal, 5 electrons will flow from B to A, and what will happen? This 5 positive charge will be cancelled, and there will be a 5 positive charge here. Similarly, by losing 5 electrons from body B, this also will become 5 positive charge. So potential difference between these two are equal, I mean 0. This is, and this potential difference are a 0 because both are same potential. Potential of A and potential of B are equal. So their difference are 0. So the flow stopped. After that, we are removing this charged source body, and we are separating these A and B. What will happen? Now there is an excess of electrons, and B has an excess of deficiency of electrons. So these electrons on A will uniformly distributed. So A become negatively charged. Similarly, here on the B, the positive charge will uniformly distributed on the surface of the material, and it will become positively charged. So at the same time, we can make one object positive and other one negative using this second method, right? Clear, right? Now I have a question for you. How can you charge a metal sphere positively without touching it? Same thing what we have learned. I will show you a video. See, we have a metallic uncharged sphere mounted on an insulating metal stand. We are bringing a negatively charged, not glass rod, plastic rod we are bringing. So this area, see, electrons are repelled. So this area become positive and this area become negative. We are grounding, see, grounding. What will happen? These electrons will flow to the earth. There's a potential difference between earth and this. So this area accumulated with positive, and here all the accumulated electrons flow into the earth. Now we are removing this contact with the earth. What will happen? This body has a deficiency of electron. Now we have removed the charged source body. So this positive charge will be uniformly distributed. So thus the body is positively charged. Body is positively charged. Now, the same thing we can discuss step by step. Once again, figure A shows an uncharged metallic sphere on an insulating metal stand. Bring a negatively charged rod close to the metallic sphere as shown in figure B. Okay, can be a plastic rod, rubber, PVC, etc. As the rod is brought close to the sphere, the free electrons in the sphere move away due to repulsion and start piling up at the farther end. So these electrons near to this one get repelled, so they are piling to the farther end. So automatically this area will become positive. So the near end become positively charged due to the deficiency of electrons. This process of charge distribution stops when the net force on the free electron inside the metal is 0. So their net force becomes 0. The attraction between this and this positive, this negative, and negative repulsion, all net force is becoming 0. Now connect the sphere to the ground by a conducting wire. See, using a conducting wire, we are earthing it. So electrons will flow to the ground, while the positive charges at the near end will remain held there due to the attractive force of the negative charge on the rod as shown in figure C. So all the negative charge is flown to the earth. But what happened? This positive charge will remain here due to the presence of this source negatively charged body which we brought near to this metallic object. Disconnect the sphere from the ground. So we are removing this grounding. The positive charge continue to be held at the near end because this charged source negatively charged body is near there. So this positive charge will remain there. Now remove the electrified rod. This rod, electrified rod, we are removing this one. What will happen? The positive charge will spread uniformly over the sphere as shown in figure E. See, is uniformly distributed. Okay, so let us go for a question answer session. Differentiate charging by conduction and charging by induction. Differentiate charging by conduction and charging by induction. So what are the main points? In conduction, two bodies are coming in contact, while in induction, they do not touch each other but come closer. In induction, total charge of the body remains unchanged, while in conduction, it changes. In induction, induced charge is always opposite in nature to that of source charge, while in conduction, charge on two bodies is of the same nature. So these are the main three differences. So in conduction, two bodies are coming in contact, but induction, the two bodies are coming close to each other, but they are not coming in contact. Secondly, in induction, total charge of body remains unchanged, right? Unless otherwise we are grounding or bringing and touching with another neutral body, the total charge of the body remains unchanged, right? One area will become positive and other area will become negative. If you remove the charged body, electrified body, then all this charge will be neutralized. But only if we are grounding or bringing another neutral body and making them contact, then the charge will flow and it will become as a permanently charged body. Third point is in induction, induced charge is always opposite in nature. If you are bringing negatively charged body to a metal, what will happen? The near part will become positively charged. Opposite charge is inducing, right? But in conduction, if you are bringing positively charged body and making contact with neutral body, this positive charge is sharing. So neutral body is getting same charge, right? So in conduction, neutral body is getting same charge, but in induction, neutral body is getting opposite charge. So these are the main three differences in conduction and induction. Okay. Now, I told you there are three more ways for charging a body or getting charge on a body. So let us make a brief on that. First one is charging by photoelectric effect. When light of sufficiently high frequency is incident on metal surface, then some electrons come out and metal gets ionized. See here, light rays are coming and falling on this metallic object. So in this metallic object, the atoms have free electrons, right? Free electrons. When the light is coming and falling on this one, right? Photons with a sufficient threshold energy coming and hitting on the surface, the free electrons will be emitted. Electrons emission is taking place. See, electrons emission. So there will be a deficiency of electrons. So we can say this has a positively charge. This object has a deficiency of electrons. So this body has a positive charge. This is one way. Another way, charging by thermionic emission. What is it? When the metal is heated at a high temperature, Then some electrons of metals are ejected and the metal gets ionized. It becomes positively charged. See, we have a metal heating. So electrons are ejected. So there will be a deficiency of electron. So we can say this object has a positive charge. It means ionized, charged. See here, heating. So free electrons getting emitted, thermionic emission process is taking place. So since there is a deficiency of electron, this object will be positively charged. Clear, right? Next, charging by field emission. What do you mean by charging by field emission? When electric field of large magnitude is applied near the metal surface, then some electrons come out from the metal surface and the metal gets positively charged. See, we are applying a electric field of large magnitude. Electric field of large magnitude. What will happen? Electrons will be ejected. Electron will come out. See, these are emission of electrons are coming out. In this figure, you can see electrons are coming out. So what will happen? There will be deficiency of electrons. So this metal gets positively charged. Okay. So now we have learned 6 methods. 3 methods are mainly coming in this chapter. Other 3 methods, just in details, we will learn in different chapters. But now we are making a basic idea. Okay. Hope you understood all the points, topics clearly. If you have any doubts, you can contact me in my email address, or you can WhatsApp me. Online students can ask me in the live classes if you have any doubts. Okay, so learn well. See you in the next class.